Imagine you are holding an apple. If you want to know what is inside, it is easy. You just take a bite or cut it in half. But what if that apple is the Earth, with a massive radius of nearly 6,378 kilometers? You can't just cut it open. The deepest we have ever managed to drill is a 12-kilometer hole in the Arctic. To put that in perspective, if the Earth were an apple, we haven't even pierced through the skin. So how do scientists actually know that there is a solid inner core and a liquid outer core miles beneath our feet? They use the Earth's hidden signals. Welcome to our topic, the interior of the Earth. Since we can't physically travel to the center of the Earth, our information comes from two types of sources, direct and indirect. Direct sources are things we can actually touch and test in a lab. We get these from deep gold mines, about 3 to 4 kilometers deep, massive ocean drilling projects, and volcanic eruptions. When a volcano erupts, it literally vomits up molten magma from deep inside the Earth, giving scientists a perfect glowing sample of the Earth's internal chemistry. But direct sources only scratch the surface. To see the deep interior, we need indirect sources. Scientists use magnetic surveys, they study meteors, which share a similar composition to Earth, and they measure gravity. But the absolute most important powerful tool they use? Earthquakes. Let's talk about why the Earth shakes. The crust of the Earth isn't one solid piece, it is cracked. These massive cracks are called faults. The giant slabs of rock on either side of a fault want to slide past each other, but they are locked tightly by extreme friction. Eventually, the pressure builds up so much that the friction snaps. The rocks violently slip, releasing an explosive amount of energy. The exact underground point where that snap happens is called the focus. The spot on the surface directly above it is called the epicenter. When that energy releases, it blasts out invisible shock waves called seismic waves in every single direction. These waves are the ultimate X-ray machine for the Earth. There are two main types of waves. P waves, primary waves. These are extremely fast. They move like sound waves, pushing and pulling the Earth. The most important thing about P waves is that they can travel through anything: solid rock, liquid magma, or gas. S waves, secondary waves. These arrive a bit later and move up and down. But S waves have a massive weakness. They can only travel through solids. If an S wave hits a liquid, it completely stops. When a massive earthquake happens, scientists all over the world check their seismographs. They notice something incredible. At certain distances from the earthquake, specifically between 105 degrees and 145 degrees away, their machines recorded absolutely nothing. This dead space is called the shadow zone. Why is there a massive shadow zone? Because deep inside the Earth, there is a giant pool of liquid metal. When the S waves hit that liquid outer core, they completely die. When the P waves hit it, they bend sharply, creating a blind spot on the other side of the planet. Just by watching how these waves bend and die, scientists mapped out the exact layers of our planet. So what exactly did they find down there? The Earth is built in three main layers. The crust, the brittle outer skin we live on. It is about 5 kilometers thick under the oceans and up to 70 kilometers thick under massive mountains like the Himalayas. The mantle, the thickest layer, extending down 2,900 kilometers. The upper part of the mantle has a weak melting zone called the asthenosphere, which is where all that volcanic magma comes from. The core, the heavy, dense center. The outer core is liquid metal and the inner core is a solid ball of iron and nickel, Ni-Fe, under absolutely crushing pressure. Now when that hot magma from the asthenosphere finally breaches the crust, we get a volcano. Not all volcanoes look like the steep, explosive mountains you see in movies. There are several types. Shield volcanoes. Huge, broad, gently sloping mountains like in Hawaii, made of very fluid, runny lava. Composite volcanoes, tall, steep, and highly explosive mountains made from thick, sticky lava and alternating layers of ash. Calderas, volcanoes that are so violently explosive that they don't even build a mountain, they just completely collapse in on themselves, leaving a massive crater. Flood basalts. When the crust literally cracks open and highly fluid lava floods massive regions for miles. The Deccan Traps in India were formed exactly like this. But sometimes the magma never actually makes it to the surface. It gets stuck inside the crust and cools down incredibly slowly into massive underground rock formations called intrusive forms. These hidden underground structures have cool names based on their shapes. Batholiths, gigantic deep domes of cooled magma that only appear on the surface after millions of years of erosion. Laccoliths, large dome-shaped bodies that sit closer to the surface with a flat base connected to a magma pipe. Sills, flat horizontal sheets of cooled lava trapped between rock layers. Dikes, when magma shoots straight up vertically through a crack in the rock and cools into an underground wall-like structure. These are incredibly common in western Maharashtra. So the next time you look at a simple rock or feel a slight tremor in the ground, remember, you are standing on a massive, dynamic, multi-layered machine. We may not be able to dig to the center, but by listening to the Earth's violent tremors and watching its fiery volcanoes, we have mapped out the very heart of our world.